Our group topic is cost-benefit analysis of the Fangcheng port project in Guangxi, China. First, let me do a project overview. The Fangcheng port expansion project is one of the important development axes for land-sea linkage in the Guangxi region. It aims to strengthen its function as a major sea access route for inland provinces by adding one container berth and one bulk cargo berth. Secondly, the project focuses on serving international trade goods and coastal logistics distribution. The total investment of the project is approximately $100 million. Thirdly, the Fountain Highway connecting Nantan and the Fangcheng Port is being built as a supporting project. The investment in the highway project is $54 million. We will analyze from two perspectives. Perspective 1. Net social benefit analysis and improvement recommendations for the Fangcheng Port project. Perspective 2. Analysis of overlooked opportunity costs in the Fangcheng Port project.
One of the questions we're going to present is the net social benefit analysis for this project. Assessing whether social costs are fully internalized, identifying negative externalities, and proposing improvements to enhance the net social benefits. For calculating the net social benefits, we use the formula NSB equals private benefits plus social benefits minus private costs and minus social costs. Private costs is quantified in the article, which is in total $69.8 million, including $11 million for the port and $58.8 million for the highway. But there are a few items not quantified exactly, so that kind of costs and benefits may be ignored by the decision makers, and the whole estimation of the project will be inaccurate. So in order to make the estimation more practical, we add some estimates of a few items. For social costs, we consider ecological damage, noise pollution health costs, and resettlement psychological costs. For private benefits, we include trade volume increase and new jobs created by this project. And for social benefits, we add travel time savings and health benefits from environmental improvements. Let's go through the detailed estimation steps. In terms of social costs, there are three parts. For calculating ecological damage, we use the method of ecosystem service valuation. We assume port construction impacts 100 hectares of marine ecosystems, with a coastal ecosystem value of $4,000 per hectare per year lasting 10 years. And the total calculation is $4 million for this damage. And for calculating noise pollution health costs, we use the method of health cost approach. We assume 5,000 residents affected by noise with an annual health cost of $100 per person lasting 10 years. And the total calculation is $5 million for this cost. And for resettlement psychological costs, we use the method of psychological cost estimation. We assume 10,000 residents resettled with a psychological cost of $500 per person, and the total outcome for this cost is $5 million. And the private benefits include two parts. We use the IRR method to calculate trade volume increase. We assume the project IRR is 21%. And total investment is $69.8 million, lasting 10 years. And the total benefits for this increase is $164.58 million. And for the benefits of new jobs created, we assume 500 new jobs created each with an annual salary of $5,000 lasting 10 years. So the total benefits of this is $25 million.
The next part is about the quantification of social benefits. The first part estimates the travel time cost reduced by highways. Our quantification method is the value of time approach. Assuming there are 6,300 vehicles per day, with each vehicle saving 30 minutes, and a value of time of $5 per hour based on wage levels in low-income regions of China. The value of time saved over 10 years amounts to $57.4875 million. The second part estimates the benefits from improved air and water quality. We use the health benefits of environmental improvement method for quantification. Assuming the improved air and water quality reduces annual health expenditures by $50 per person for 10,000 people. The total benefit over 10 years is $5 million. Adding the two together, the total social benefit is $62.4875 million. Finally, after quantifying the four parts mentioned above, we can calculate the net social benefit. The total cost equals to $83.8 million. The total benefit equals to $234.0675 million. The net social benefit is the total benefit minus the total cost, which equals $150.2675 million. Therefore, the conclusion drawn from the cost-benefit analysis is that the net social benefit of the project is positive, indicating that it's socially worthwhile overall. However, another important aspect we focus on is whether the social costs have been fully internalized. First, we assess the effectiveness of the current mitigation measures. On the port side, environmental mitigation costs amounted to $1 million, including reduced dredging and the construction of a wastewater treatment plant. These measures helped reduce some water pollution but failed to address the long-term ecological damage, which are estimated to $4 million. On the highway side, the environmental mitigation and resettlement costs were $4.8 million. However, noise pollution costs and the psychological impacts of resettlement were not fully considered. Thus, the total mitigation cost is $5.8 million. The internalization ratio is calculated as 5.8 divided by 14, which equals to 41.4%. The remaining were not covered in the project budget, leading to an underestimation of the total social cost. Next, we discuss the negative externalities caused by the social costs that have not been internalized. First, there is ecological damage. Water pollution and the loss of marine life will lead to a decline in fishery yields, affecting fishermen's livelihood. And there is noise pollution. Noise generated by highway operations will lead to health issues among nearby residents, lowering their quality of life. And it will also cause social inequality. The psychological costs of resettlement may affect low-income families, who often lack the resources to adapt to a new environment. But we can improve project design to enhance the net social benefit. In terms of ecological protection, we can upgrade the wastewater treatment plant and ecological restoration measures to strengthen ecosystem resilience. And the water quality monitoring system should be established to regularly check pollutant concentrations. To mitigate noise pollution, we can install sound barriers along the highway and plant high-density trees to reduce noise. And we can build a system to monitor noise levels. Regarding community support, psychological compensation such as access to counseling services should be provided for relocated residents, who can also offer medical subsidies to those affected by noise pollution. Finally, policy tools can be introduced. A pollution tax could be levied on port operators, and the pollution emission trading market can also be established to incentivize companies to reduce pollution. In summary, based on the comprehensive assessment and quantitative analysis of private costs, social costs, private benefits, and social benefits, This project generates a net social benefit of $150.2675 million, confirming its overall socio-economic viability. And only 41.4% of the social costs were internalized, leading to negative externalities. There are also improvement measures that can increase internalization ratio and reduce negative externalities, including ecological protection, noise mitigation, community support, and policy tools.
Next, we discuss question 2, analysis of overlooked opportunity costs based on land and ecology, alternative uses, and labor. Let's begin with the port expansion project. The expansion requires large-scale dredging and the installation of hard infrastructure in the coastal area. This process will cause irreversible impacts on nearshore water flow, mangrove wetlands, and related ecosystems. It is worth noting that the project site is one of the most densely distributed mangrove areas in Guangxi. However, in the project evaluation documents, the area was assumed to have no other valuable use. As a result, the ecological cost was not quantified. The value of ecosystem services is not always reflected in market prices. In such cases, shadow pricing should be applied to evaluate their true value. Take the carbon sequestration function of mangroves as an example. If the construction area covers around 100 hectares of wetlands, the annual loss in ecosystem services would be about 105,000 RMB. When discounted over time, the total loss could reach several hundred thousand RMB or more. From the perspective of regional economic development, this coastal land has potential for development into an ecotourism site. According to official statistics from Fangcheng, the city received more than 34 million domestic tourists in 2023, generating over 31.6 billion RMB in tourism revenue. The growth trend is clear. Referring to the development experience of Hailing Island in Yanjiang, Guangdong, if Fangcheng could develop a medium-sized ecotourism zone, the annual direct tourism revenue would be comparable to the increased cargo throughput of the ports. Moreover, this estimate excludes indirect benefits such as services sector expansion, job creation, and city brand enhancement. It is therefore considered a conservative evaluation. Now we shift to the efficiency of resource use in the highway construction project. According to the project data, about 1/3 of land acquired is farmland. The one-time compensation standard is 18,000 RMB per mu. Let us assume an annual income of R if it were used for agriculture and project. The lifespan is T and the social discount rate R. The opportunity cost of agricultural output can be estimated using the following formula. And we can find that this value is significantly higher than the current one-time compensation, indicating that the actual social cost of land has been underestimated. In terms of transportation planning, there are feasible alternatives. Take the Chongzuo-Pingshan Railway as an example, whose information is written in this table. Railway offers advantages over highways in terms of land use, transport efficiency, and carbon emissions. If Fangcheng has adopted rail or multimodal transport systems, it might have achieved the same transport goals with reduced farmland loss and better environmental outcomes.
In this part, we analyze the social cost of labor input of this project. Here we discuss whether it is reasonable to use budgetary outlay to measure the opportunity cost of labor force used in this project under 3 different situations. The first one is an easy situation that the market is efficient and the government doesn't interfere the market. In this situation, we assume that the labor required by the project is small relative to the overall labor market, meaning it won't affect wages. Thus, the labor supply curve is horizontal, indicating constant wages regardless of demand. The project needs key units of labor, and the cost per worker is P0. Then total government spending is simply P0 times Q. This amount equals to the area represented by the rectangle AB Q1 Q0 under the supply curve shown in the figure in the right-hand side, which reflects the opportunity cost of hiring these workers. In short, in this case, it is reasonable to use the actual spending in our calculation. The second situation is an efficient market with noticeable price effects. According to statistics from Fangcheng City, between 1997 and 2001, the city's population was approximately 772,000. Of this total, about 60% were of working age. Additionally, only around half of the population resided in urban areas, while the other half lived in rural regions, where most people were farmers and engaged in the planting industry rather than construction industry. Therefore, the number of workers available for non-agricultural industries in urban areas was approximately 231,000. This indicates that the labor supply in Fangcheng was relatively limited. As a result, the increased labor demand brought about by this project will likely lead to a significant rise in the market labor prices. Then we look at a more realistic model to measure the social cost of labor force of this project. Here we still assume no government interferes, but the increased demand shifts the labor demand curve to the right, pushing wages up from P0 to P1. The project's labor cost paid by the firm of government becomes P1 times Q. But there's a broader impact on the total society. The original employer's consumer surplus decreases by A plus B due to higher prices and the crowding out effect of government programs. For employee, the producer surplus increases by A plus B plus C, the actual cost of the project because of higher labor in B plus C plus E plus F plus G. Overall, the social surplus decreases by B plus E plus F plus G. We can see that the social cost of labor exceeds the wages paid by the government, as indicated by area C. If the area C is small enough, we can just use the budgetary expenditure to approximate the real social cost of labor force. In the third situation, we assume that the project hired employers from the unemployed workers. This can also be reasonable because back in 2000, the minimum wage in Guangxi was 200 yuan per month, which might have been higher than the market equilibrium wage. That could cause unemployment. We assume that the project hires from this pool of unemployed workers. For simplicity, we also assume the labor supply curve starts at 0 and slopes up to the right. Unemployed workers are evenly spread along the supply curve between E and G. Their average salary is 0.5 times PM, so the true social cost becomes 0.5 times PM times Q, which is only half of what the project is spending. So when hiring the unemployed, actual spending overstates the social cost. Based on the previous analysis, we believe that the third model is a better measure of labor social cost in this project. In this context, government budgetary spending is not a good measure of the labor social cost. We should multiply the budgetary spending by 0.5 or a factor between 0.5 and 1, because not all of the newly hired workers were previously unemployed to get a true labor social cost.
In the end, let me do a conclusion of our analysis. Firstly, based on the comprehensive assessment and analysis of private costs, social costs, private benefits, and social benefits, this project has generated a certain amount of net social benefits, which confirms its overall feasibility and the social economy level. However, less than half of the social costs have been internalized, leading to negative externality. Secondly, the project did not adequately account for its opportunity costs. The coastal area had potential for ecotourism and ecological preservation, while the long-term value of farmland exceeds the compensation provided. Viable alternatively, such as rail transport, were not seriously considered. A better evaluation should include shadow pricing and compare different options to guide smarter public spending. Consider the impact of the hiring from non-employed workers and notable price effects. Government budgetary spending is not a good measure of labor social costs. The actual social cost should equal a factor which is between 0.5 and 1 timed government budgetary spending. Thanks for watching. That's all of our topic.